In this video, I'm going to talk about critical point, and then I'm going to talk about how to use this critical point notion to find extreme or absolute maximum or minimum values for a function in a certain interval. So let's define what a critical point is, or sometimes it's also known as critical number. So let's say you have a function f, okay? And let's say some number c is in the domain of that function f. So if the derivative of f at that point c is equal to 0 or does not exist, doesn't exist, then we call c a critical point. Then c is a critical point. So if a point c in the domain of a function is called a critical point if the derivative of the function at point c is either 0 or it doesn't exist, then c is a critical point. And we could use some examples. So let me give you an example here. So let's say your y is equal to f of x is equal to, let's say, x minus 3 whole square plus 1 maybe. So what is y prime? Y prime is going to be 2 times x minus 3 using the chain rule, using the power rule, and then using the chain rule, the derivative of x minus 3 is just 1, then plus the derivative of 1, which is 0. So let's find out for what value of x this is going to be 0. If you solve for x, you can see right here that x is going to be 3. So x is equal to 3 is a critical point for this function. Now, another example, absolute value function. So let's say this is my absolute value function. Okay, so this is y, this is x, this is absolute value of x. Now at this point, as you know, at x equal to 0, f of x is equal to absolute value of x does not have derivative, does not have derivative. So what does it tell you? It tells you that x equal to 0 is a critical point for this absolute value function because the derivative does not exist. From these two examples, as well as from Fermat's theorem, we can kind of conclude the following. So if f has a local max or mean at some point c, then c must be a critical point. Okay, f has a local extreme. By extreme, I mean either local max or local mean. Then extremes at point C, then C is a critical point. C is a critical point. That's what it is. So now let's kind of take these ideas and extend it. So let's say we have a function. So we have a function f of x, okay? That's a continuous on closed interval AB, okay? So it's a continuous function on closed interval AB. By extreme value theorem, we know that the extreme values or absolute maximum or absolute minimum values exist for this function. Now, having said that, let's find it. Let's find a procedure for figuring out what these extreme values are. First, you want to, so there's step 1. You want to find the values of f of A and f of B. That means at the boundary points, you want to find the values. Number 2, find critical points for f. Find critical points for the function f at, not at actually, but rather in the interval ab. Okay, find the critical value of the function in the interval ab. Now what do? You look at these two sets of values and evaluate the function. So step number 3 maybe, evaluate the function. Evaluate f at the points you found above. At the points you found above. And then you can go ahead and find the extreme values or absolute maximum or absolute minimum from this set of points. I hope that this discussion was helpful. Thank you very much.